You know that feeling, right? You're in the middle of a recipe, maybe baking something, and you just stare at the measurements. Cups, pints, quarts, gallons. Where did all these weird numbers even come from? It all seems so random. Well, today, we're going to pull back the curtain on the system a lot of us use every single day and find something pretty surprising, a hidden logic.
All right, let's just jump right in with a big one. Why are there 128 fluid ounces in a gallon? I mean, seriously, 128. It feels completely pulled out of thin air, doesn't it? It's not a nice, clean number like 10 or 100. It just feels like one of those facts you're forced to memorize for a test. But what if I told you there's a reason for it? That it's not random at all?
I mean, have you ever actually looked at a full conversion chart? It's just a wall of numbers. It's totally overwhelming. 1 pint is 16 ounces, a quart is 32, a gallon is 16 cups. Your eyes just glaze over. It feels like a random list of facts you have to cram into your brain. But believe it or not, hidden inside all that chaos is a surprisingly simple and kind of beautiful pattern. Yeah, the US customary system can really feel like you're lost in a maze. But you know what? Every maze has a path. And today, we're going to find it.
Okay, so to find our way through this, we need a clue. Let's narrow things down and start with something familiar. Liquid volume. You know, all the stuff you use in the kitchen every day.
Yep, our whole investigation starts right there, in the kitchen. Because the secret to this whole system, it's been hiding in plain sight this whole time, right there with our measuring cups. So, let's start with the absolute basics, our foundation, the humble measuring cup. We'll build everything from here. All right, first fact. 1 cup equals 8 fluid ounces. Let's just lock that in our minds. This is the key. Everything else is going to build off this one piece of information. Okay, here's where the fun really starts. We've got our starting point. So what happens when we go up to the next unit, the pint? Is there some kind of logic here, or is it just another random number we have to memorize? And the answer to that question, well, this is the good part. Because we're about to find a super simple, repeating pattern that makes this whole thing just click. Okay, check this out. We start with our 1 cup, which is 8 fluid ounces. Now, what's a pint? It's just 2 cups, right? So, what's 2 times 8? 16. And boom, suddenly 16 fluid ounces in a pint isn't some random number anymore. It's literally just double a cup. All right, that's pretty cool. But is it just a fluke? A one-off coincidence? Or is this a real pattern? Well, to find out, we have to go one size bigger, to the quart. Let's see if our logic holds up. And yes, it works perfectly again. We take our pint, which we know is 16 fluid ounces. A quart is just 2 pints, so what's 2 times 16? 32? The doubling pattern is real. So this is the key insight right here. It's this simple, elegant rule that's been hiding in plain sight all along. From a cup to a pint, you just multiply by 2. From a pint to a quart, you multiply by 2 again. It's not random. It's predictable. But wait, just when we think we've totally cracked the code, we run into the final boss of kitchen measurements, the gallon. And yeah, this is where the system throws us a little curveball. So here's the twist. We had this beautiful, clean doubling pattern going. Cup to pint is times 2, pint to quart is times 2. But the jump from a quart to a gallon isn't times 2, it's times 4. This is the one and only exception to our neat little rule. And that final jump, that's how we solved the mystery we started with. Remember the 128? Well, a gallon is 4 quarts, and we figured out a quart is 32 fluid ounces. So what's 4 times 32? 128. It all connects. That number that felt so random is actually the perfectly logical end to this pattern of doubling, with just one bigger jump at the end. So, okay, we found the pattern. That was a fun little bit of detective work for sure. But why does this actually matter? What's the real takeaway here? Well, it matters because it completely changes how you look at this stuff. You're not just trying to cram a bunch of random facts into your head anymore. You've moved past simple memorization and into actual understanding. Now you have a system, a logic that you can actually use. You know, it's such a cool contrast to the metric system. Everyone knows metric is super logical, right? It's all based on tens. But the US system, it feels more, I don't know, organic. Like it wasn't designed by scientists in a lab. It just grew over time, based on a really simple human idea. Let's just double it. And really, that's the bottom line. You can pretty much forget about that long, confusing conversion chart. All you really need to remember is the doubling pattern, cup to pint to quart,
And then that one little exception, the jump to the gallon, is times 4. That's it. You've just mastered the entire system. And really, this isn't just about measuring milk for a cake. It's about a whole way of looking at the world. It just goes to show that even in systems that seem totally chaotic and random on the surface, there's often an elegant, simple pattern hiding right underneath. So the question I want to leave you with is, what other hidden patterns are out there just waiting to be discovered?